a little more exciting here. Ooh, not lo-fi metal beats distress too, like that. Yes. Maybe a little bit much for you guys.
What we're gonna do right here is go back, way back.
Let's do this. There we go.
Come on, everybody, we're late. Bart, I want you to promise me you'll pay attention in Sunday school. Bart? Bart? Bart!
Are you talking to me?
What's this? A personal stereo. Were you going to listen to
Vaporwave.
in Sunday school?
Maybe.
Can you believe this, Homer? Homer?
Of watching the other professors I follow go live at the same time. No. Balance. Could have it backwards. Right. Poop. That's not gonna work. Hey, there we go. Neat. Hey, stuff's working. Kinda. This is not related to class whatsoever. Well, I guess kind of. I'm thinking with my term project. Ooh. Snazzy. Hey, it's animated. That's new. Alright, 1 o'clock. How are we all doing today? Headache. No! Sorry to hear that. Doing alright? I hope that goes away soon. Leave that tea in for a bit longer. Alright. Okay. Somebody introduced me to, oh, what was that? Shoot. It's a spoof of the lo-fi girl. It was kind of funny. Let's read. There we go. Colby Benjamin. Kind of funny, I thought. Nice little rap-esque spoof. Good stuff. Alright. Close. Close and fade out. Neat. Alrighty. So, mentally dead. Ooh, prescription. That's no fun. As a chronic headache sufferer myself, I feel your pain. But hopefully that goes away soon. Alright, so I've got the Blackboard page open. Reason being, I was seeing some chatter in the Discord that people might not have been aware of the project due Tuesday night next week, the 29th. It's the last item to be done. Work on the project proposal. Check it into your GitHub repo for your team. Shouldn't be all that hard, I would think, to fill out, but it requires some coordination from your part, so please make sure that you talk about it as a team. What we're going to do today is requirements, and it is going to be super exciting. So what we're going to do is we're going to start off with something that hits very, very close to home. Have any of you ever seen The Expert? It is a 7.5-minute sketch of what life is actually like. I have. Oh god. Haha. I'm only going to show you the first minute or so, because I can't watch the whole thing any longer. But I would recommend checking it out if you've never seen this. So I'll just drop it in here, and I want you all to get a feeling for what industry is actually going to be like for you, the developer.
Our company has a new strategic initiative to increase market penetration, maximize brand loyalty, and enhance intangible assets. In pursuit of these objectives, we've started a new project for which we require 7 red lines. I understand your company can help us in this matter.
Of course. Walter here will be the project manager. Walter, we can do this, can't we?
Yes, of course. Anderson here is our expert in all matters related to the drawing of red lines. We've brought him along today to share his professional opinion.
Nice to meet you. Well, you all know me. This is Justine, our company's design specialist.
Hello.
We need you to draw 7 red lines, all of them strictly perpendicular, some with green ink and some with transparent. Can you do that?
No, I'm afraid.
Let's not rush into any hasty answers, Anderson. The task has been set and needs to be carried out. At the end of the day, you are an expert.
The term red line implies the color of the line to be red. To draw a red line with green ink is, well, if it's not exactly impossible, it's pretty close to being impossible.
What does that even mean? Impossible.
I mean, it is possible. There are some people, say, suffering from color blindness, for whom the color of the lines doesn't really make a difference. But I'm quite sure that the target audience of your project doesn't consist solely of such people.
So in principle, this is possible.
I'll simplify. A line as such can be drawn with absolutely any ink, but if you want to get a red line, you need to use red ink.
What if we draw them with blue ink?
It still won't work. If you use blue ink, you'll get blue lines. And what exactly did you mean when you talked about the transparent ink?
How to better explain?
Yes, that's about all I can take. There is another 6 minutes left on that, so feel free to check it out at your leisure. It is wonderful, and it's pretty much real, unfortunately. But what they're doing is you had some different roles there. So you had your project manager, who was just assuming that the expert could figure it out. You had you, I assume you, the engineer, telling the people who don't understand that what you're asking for is technically impossible. You have your customer person, who is just, conducting the market research, and your, would that be your, probably be a level up from project manager, defining everything for you. So it's a lovely look into real life. Obviously a spoof. But hey, if you can figure out how to draw 7 perpendicular lines in 2-dimensional space, I'd be very impressed. And why is that relevant? Well, they are defining requirements for a project. And that's what we're going to be talking about today. So we're going to go over requirements at multiple levels. We're going to talk about what they are, what their role is. We have some different levels of requirements, different types of requirements. And then we'll go through the process. I don't know that we'll get all the way through this today. We may not. But the point I want to kind of get across today, obviously we can go through all the technical aspects of how to write a requirement and what they are. But the thing that you really need to get across is that this is probably the most important part of the software engineering process, honestly. I'm not going to read this quote to you. It's a great quote, though. But what I would like you to do is, while you read it, think about these last 2 sentences, and I'm kind of curious to see what your thoughts are. So why is this person saying these things? Why is it so important? Hmm. Why are requirements so important? Different team members could have different goals and end results. Sure. So if you don't structure your requirements appropriately, then nobody's going to know what to program, right? So they will end up with a different product, right? User might not know exactly what they want. Oh yes, let's get our requirements from the user, which is part of it. We would have a state where we ask the user what they want. They are generally vague with what they're looking for, and it's really hard to nail down a particular requirement. So we might build a system that we think they want, but they might not actually get what they're expecting. Absolutely. One other thing too. So let's say if you make something that turns out not to be what you intended, you might have to start from scratch. Yeah, that was the other part too. Absolutely. So think of those software processes we talked about, the last couple of times. If you screw up a requirement and you don't realize it till the end, if you're in waterfall, you have to go all the way back, or some variant thereof, right? If you're doing agile, you may have to rework your user stories, or you may have to redo some sprints, or make some more more story cards. It depends on what your process is. If you're prototyping, again, you're gonna have to go back and revisit your requirements, create new prototypes, and yeah, I think I just wasn't used to Bash separate from Linux or Mac shell. Yeah, I will say that not to diverge too far, but the fact that you can run Linux on Windows now, like this, I've been looking for this for probably 15 years. Not Sijuan. Sijuan is a pain to me, but just native Linux commands in Windows makes me so happy. It's exactly what I've been looking for. So I love it. I'm sure it'll get maligned later on, but right now it's great. So yes, requirements are very, very, very important, and getting them right is effectively an art in and of itself. So let's make sure that we do a good job with this. So what are they? I've been hinting at this for probably, what, 2 weeks now, that requirements are important and we really are going to have to work on them at some point. And you'll all be defining them for your projects in the near future as a bit of a look ahead. But consider a requirement. It's something written in natural language, so it's prose, but it is capturing some functionality or some kind of a condition or a constraint. Just thank you. I'm glad somebody got that. But consider a requirement to basically be telling you exactly what your system is and is not doing, right? So I might be defining a feature, right? What kind of information do I need from this form, or what kind of algorithms need to be running to parse out data later on, right? We might not specify exactly which algorithm, just that we have to parse something out. We might also put constraints in there. So your system has to operate within a certain voltage range, or your particular function has to return a value that is Boolean in nature, or it has to be within a particular range, or the data type has to be specific. So we are getting very explicit in our function, or in our system definitions. So there are specifications of what, in bold, should be implemented in bold. We're describing behaviors, we're describing attributes, we're describing properties, constraints. Make sense? Key thing to keep in mind here is that requirements are still a layer above implementation. So I'll tell you this early, we do not want to put implementation details in our requirements, right? That's going to be our programmer's job to figure out which programming language they need to use, or which modules need to be imported, which algorithms specifically need to be run, right? What databases we have to be running behind the scenes. You don't say at the requirements level that you need to have a NoSQL database like Mongo, for instance, or CouchDB or Neo4j if you're going graph-based or something like that. You don't say that. That's up to the programmers. That's more at the implementation level. You say we need to store data in a database of some kind. Do it. Yes. Play D&D. It's a wonderful game. So we are a little bit higher of a level above implementation here, but we're specifying what the system has to do. We have some different levels of requirements in here. So they are not strictly for creating your system. You're also looking at things at the business level or the customer level. Now, these types of requirements are, again, we're a few levels removed from the nitty-gritty of the actual project. These are your business type requirements, right? So these are going to be things like, how do we transmit information to our customer? How do we move our business forward using these products, right? At this level of requirements, you're not going to be talking about the system itself. That's farther down. Here you're talking about how this project is going to impact your core business principles or your portfolio or something of that nature. These will be in a different document for all intents and purposes. So it'll be in like a vision document or a scope document where you're basically outlining the project. What's the scope of it? How does it impact and move your business forward? Right, so high level things. We're also going to have a user level. So these are where you have features that impact your users. Okay, so what kinds of interactions will they have? These may be use cases, types of like use cases where you're showing how external entities interact with a feature, right? Are they using a touchpad to interact with your application? Are they getting data through some kind of an API to their particular, you know, local instance. We also describe quality attributes that impact the user. Again, key with the user level is the term user. It impacts that person using the device or the project, whatever it is going to be, right? And then we get into the meat of this, the implementation level. So these are going to be the majority of what we talk about today. These are requirements which are implementation specific. So we break them into two types. There's functional and non-functional, and we're going to get into that very, very soon here. Basically, we are defining system behaviors and the quality or how these behaviors are expressed, right? And these are going to be in a very, very, very large document called a software requirement specification. This SRS, if you have any friends that have ever taken a software engineering course before, this was your final project, was just to write this document. They can be 80 to 100 pages long, and it's basically like a dissertation in terms of the amount of content that's in there. We will do a light version of this, but this will capture everything you need to know about a system. Right. Key thing here, though, are these functionals and non-functionals. Right, so just to kind of give you the highlights again. So business requirements, user requirements. Here's what we have at a high level of what they are. Again, we already kind of talked about these in the last slide. But when we get into the functional side of things, here's where you start bringing in the term developer, right? Here's where you start bringing in the term system or product. So here we're building functionalities, features, constraints into our project. All right, so we may have functionalities in there that help out users. We may be creating tasks in there that satisfy our business objectives, but they're going to be very specific in terms of how it's to be implemented in that nature. So we have functionals and non-functionals, and these are again implementation specific. Okay, so point I want you to have thus far is that business level, high level, then user level, and now functional and non-functional requirements. So that's kind of where we are at. Functional requirements, we may also call them behavioral requirements. We might basically consider them to be defining what behaviors our system features are going to be expressing. So when I say expressing, that basically means that you, the programmer, has written some code and that exhibits some kind of a behavior. Right, so if one of your requirements is to write a function to encrypt a password, right? The behavior that's being expressed is that you have a hashed password at the end. So that's the behavior that I'm kind of talking about here. Now, I'm going to kind of skip through this one a little bit to get to kind of the meat of, actually, no, let me backpedal a little bit here because we go into the non-functional next. The one thing that's not really on this slide, which is very important to consider, is that functional requirements are very, very easy to test or validate. And what I mean by that is a functional requirement is going to have some kind of a metric built into it generally. Something that we can easily write, say, a unit test for, or a test case of some kind. Right, so if we go to the example of the password has to be encrypted, well, I can very easily write a test case saying, is the password the same going in as going out? Right, so if it's in plain text, we've violated our test. Or, we might be expecting it to be encrypted to a particular level, like an encryption level of 256 bits or something like that. Right, so is it SHA encrypted or is it MD5 encrypted, or whatever our encryption scheme is, has it changed? That is something that we can very easily test. We can go to the low level, the unit testing level. We might be expecting a particular data type out of a function. Well, again, that's very easy to test. We can write like an assertion for a function where is the output Boolean, or is the output within 1.0 and 10.0, right? So these types of things are very straightforward, very logically easy to follow. I'm trying to think of some other examples here for you. Basically, very, very firm requirements. Okay. And if that doesn't make sense, I'm doing a lot of hand waving on camera here, I realize. But let's say we move on to non-functionals. This will hopefully give you the other side. So non-functionals are going for your quality types of requirements here, and these are things that are a little bit harder to nail down. These are colloquially known as your ilities. So usability, security, maintainability, performance, but performability, I suppose. Basically things that are hard to really measure without, say, detailed user studies or something of that nature, right? I want my user interface to respond very quickly. Okay, what does that mean? Does it mean that I touch a button and you get a response within a second or a microsecond or a millisecond, right? So what is performance? What is security to you? My system must be secure. Okay, well, that's not helpful to anybody, right? My system is encrypted using a particular scheme, which, passes all of these common security penetration tests. That's a little bit more detail there. But the system is secure doesn't tell me anything. This could be a non-functional requirement where we are saying that we have to, be thinking about this, and then we will refine that requirement to be more specific. But the key is that these are quality attributes, right? These are more not fluffy, but they are, they're more specifying how things should be, I suppose. Functional requirements are getting us our behaviors. They're getting us our functional side, our actual implementation. Here's how these things should look. Interestingly, the non-functionals tend to be more critical because they're describing important concepts, but with less rigor, less rigorous detail, if that makes sense. So does that delineation kind of make sense to everybody? I'm going to make sure that I'm explaining this right. So the TL didn't listen, so TLDL. Functional is giving you what the system does. Non-functional is giving you criteria about the system. So your system should be performant. Your system should use little memory. It should be run very optimally on battery power. Again, very important concepts, but hard to define. So those have been kind of my, ham-fisted examples of some of these requirements. Anybody have any ideas what some other types of requirements would be? Say like what's a good functional or non-functional requirement that you can think of? I forgot to take the tea thing out. It's getting bitter. We'll highly recommend something like this. Any of you are tea drinkers, go loose leaf. It's so much better. System requirements, hardware-wise. Yeah, so that would even be a layer above. Facts. Also tease what happens when I can't handle any more coffee today. So yeah, if you're looking at a system requirement, that would be another, basically a level. So you're kind of specifying requirements for the system as a whole. Yeah, that would be true. I guess I'm kind of curious, anybody have any good examples of a functional or non-functional requirement? Or are we all staring out the window at the sun thinking that Lake Michigan's only 20 minutes away? Depending on where you're at, I suppose. Maybe the engine used for the application. Functional searches the internet for cat vids. Ooh, I like that. Yeah, so we can have a functional goal saying return any video with a cat in it. That is vague enough that we could simply, we would have free reign with which search algorithm to run, which pattern recognition algorithm to figure out cats. So yeah, sure, absolutely. engine used for the application. So actually that's a good one because we don't necessarily want to specify the particular engine. So we can say that you should use a framework for, or we could specify base requirements for a framework, but at the requirement level, we really wouldn't want to specify the exact one. Right, so if you're working on a website that's database driven, I wouldn't say use Angular or use Cake PHP or React, right? That would be your decision as the programmer. I would say I need something that has a server-side component to it. So definitely some good points here. All right, so here is a couple of figures. So these are separate. On the left here is a table of contents for a software requirement spec. And basically this is just to give you an idea of how complicated these are. Well, they're not complicated, but they're just big and large. And there's a ton of paper in these if you're printing them out. But we have all kinds of information about the document. So who should be reading it, what the scope of the project is, any naming conventions you have in here, high-level descriptions of your product, and then you get into the actual requirements layer. So you have your functional requirements, right? What is the system behaviors? What are our various interfaces? So do we have dependencies on a user interface? Do we have any hardware that we're dealing with? Any other software interfaces we need to define, right? And these are linking modules together, having dependencies. Then you get into your non-functionals. So go away, Google bar. You have your performance requirements, safety constraints. So all of these things which we're going to be talking about here, this is all spelled out in a very, very large document. And this is what you will reference time and time again during the course of a project. And one thing I should say too, before we get too deep into this, is that this is a preview for the management side of things. These are all going to be entities in some kind of a system. And when I say entity, let's look at this box here. Here we have 4 requirements. These would each be put into a system of some kind, and they would be a living object. So here we have an adaptive cruise controller, which this is actually redundant because this is adaptive cruise control controller. Well, I guess that would be the controller for the control. Maybe it's not redundant. If you're not familiar, this is where you would have a cruise control, and you can set a following distance to the car in front of you, and then you would kind of match their speed if they slow down, like below what your cruise is set to. But here we have some requirements for them. So ACC controller should not increase the speed when the distance to the target vehicle is too close. So this is a good requirement in that there is some flexibility, but it still specifies behaviors. So don't increase the speed when the distance is too close. So we have some flexibility here. All right, so you're specifying behavior, don't increase the speed. Makes perfect sense, right? You don't want to speed up and rear end the other person. But this too close, this doesn't necessarily have a specific value. This could be something that would be spelled out at the user level, right? What does too close mean? Well, this could actually be referencing a preference setting. So maybe I am 2 meters away. Maybe I'm 5 meters away, 10 meters. And maybe you're like me and from the east side of the state, and you have no problem tailgating people on the highway, which is probably a very bad thing to do. But keep in mind that we have some flexibility here. We are not giving implementation details. We're not giving specific values because this is something that could be set. However, if we have like safety requirements, we might then set that, right? If you are within 1 meter, turn off the system or something of that nature. So multiple things going on here. So we have examples of requirements, and these are actually safety constraints. This particular, each of these would be an entry in this requirements system. I'm kind of double air quoting, hand waving, whatever you want to call it. So SSR 1.2 would be linked to a project task. That task would have code that is implemented in the system. right? So if you think back to last time, when you're writing code and you have a change or a task or something linked to that, well, this is a task that is linked to a project, which is linked to such and such and such, right? And then we started forgetting where the links went. Well, here we would have a link from our task, say to this requirement. And now we can say that this requirement has been satisfied because we have code that is in place for it. So the whole notion of traceability, of linking all your various artifacts together. This in turn would be linked to a set of test cases, right? Does this requirement actually, is the implementation actually doing what the requirement says? Right, so if we set too close to be a bunch of values in our test specs, right? So we'll talk about testing later on, but let's say we test at 1 meter, 2 meters, at 5 meters, at 10 meters. Do all of our test cases pass? If we have a failure, then there's something either wrong with the requirement or the code. So then we have to go back and check. But kind of the key thing with this document and with all of these artifacts we're talking about is they're all linked together. And we can very easily follow links to figure out exactly what problems are. So that's kind of why these steps are so important to really nail down in a real world project, right? Because not to hang here too long, but let's say that I don't implement this right. Thing to keep in mind is that the programmer and the analyst, these may be different people. So let's say that you write this requirement, and then I read your SRS and I go to implement it, I might have a completely different interpretation of what you're saying. Right? So ACC controller should provide acceleration signal when the target vehicle is no longer in the lane. Okay, so I have to program this thing to still talk when the target, which is the person in front of you, when they're gone. But maybe I don't understand what no longer in the lane means, right? Maybe to me that's the instant you cross over to another lane, or when you're considering it, it's while you're going through that transition process, right? So that's why we have all of these kind of layers of review, of testing, and traceability between all these artifacts. So enough, I guess, going down memory lane to my old time at work. Let's continue down that path. This figure, I'm going to guess some of you have seen it. This was on, I would say, nearly every other cubicle wall when I was in industry. It is a great example of how projects are run. Sorry for the blurriness. I couldn't find a good clear version of it. But here's everybody's different perspective on a project. All right, so the customer described this, but they really needed this. The programmer was just lazy and wrote it like this, and we charged them a whole theme park. I still get a kick out of this figure because, again, it is so accurate. And here, something none of you are going to do. Here's how the project was documented. We have empty space. You're all going to have to do your documentation. Very, very important stuff. Okay, questions so far? Everybody good? So what we have our different levels of requirements. We have our different types of requirements. And we have very, very large sets of documentation to deal with. So that's about where we are. What we'll talk about now, assuming we're all good, is the different types of non-functional requirements. I might start being lazy and calling them NFRs because that is the shorthand acronym for these guys. So our NFRs are going to be broken down into multiple categories. All right, so we're going to have things related to the product. We'll have organizational requirements, which are going to be things from your organization, not obviously. We may have external factors to deal with, and these are going to be coming from outside of your business, outside of your environment. So we're going to basically break these all down. So first, product. So this is the leftmost branch. We might have to care about things like portability. So say that I'm writing Doom. Should I expect that it runs on a calculator, a toaster, an oscilloscope? Or should my application be portable to Android, Windows Phone? I know what's the new one, Windows Surface Book 2. What's the flappy new exciting thing? iPhone, right? So portability is going to other systems. This can be a non-functional requirement. Surface Duo, thank you. Thank you, thank you. I don't know how I feel about that because I was a Windows Phone user back in the day and I thought that was just wonderful until they dropped it. We have reliability. This is an important one, right? Especially when we are trusting systems with our life these days. Oh, it's 1400. Oh God, no thanks. No, thank you. We'll hold off until the third or fourth model. But reliability, right? These are important for any kind of an application where lots of money or lives or safety are in place. Could also be just how reliable is your product over time, right? Does it break down and it has to be replaced every year or two? Or let's pretend you're Tesla. How reliable is your AI for recognizing sky versus semi-trucks, right? So reliability is important. Efficiency. This is a nifty one for everybody to consider, even though we seem to be forgetting this as a, I suppose, cohort of programmers. Performance in space. We have a ton of space, a ton of capabilities with high-speed processing. Might as well make use of it, right? So then you end up with nice bloated Electron programs that take over your computer because there's no performance requirement specified. Or you end up with games which, are they up to the hundreds of gigabytes for a download for some of the newer games? Might even be closer to a half a terabyte. So what is the efficiency requirements of your project, right? Are you programming for a microcontroller where you actually have to consider how many kilobytes you're using? Are you programming for a modern machine where you have 32 gigs of RAM on call? 200 gigs for COD at the moment. Oof. And the sad thing is that you can probably optimize that significantly down too, but they don't. Although I'm kind of curious to see what the, not to go too off tangent, or off on a tangent, but did any of you watch that Unreal Engine reveal like a month or two ago where they were showing that real-time ray tracing of the woman going through the cave? That was so impressive, and I've got to imagine it takes up so many resources. I would recommend checking that out. That was cool. Like, I don't know if you're familiar with graphics at all, but ray tracing is, I mean, that's the RTX memes going on right now, right? But that's the current holy grail in the graphics industry, and they're finally figuring it out, which is kind of cool to see. Anyway, efficiency. Optimize your games, people. There we go. Only a few terabytes. Not too bad, right? All right, last but not least on this side, we have usability. Do you recommend a virtual machine to find out min system requirements? I mean, generally they publish their requirements online, but I'm not sure. Usability is important too because this tells you who can use your system, right? So if you are targeting a general audience, you're also going to have to consider accessibility. Like you might have to support screen readers, you might have to support color blindness. What kind of features are you building into your system for this aspect? Right, a couple of years back, pretty much every university got hammered for their websites not being accessible, meaning that they were cutting out a good chunk of their population by not being able to be read by them. So, product requirements, that's all on this branch. Then we have our organizational requirements. So, what do we have to do for delivery of the system? Right, do we have any implementation requirements? And this is getting into maybe organizational procedures, right? You have to write your code to a certain standard. You have to follow a particular formatting guide, things of that nature, right? Like where I was before, we had a requirement, and this was actually baked into our analysis tools, that For instance, every if statement had to have an else case, even if there was nothing inside of it. That's just that formatting guide. It's part of the, we did safety critical stuff, so every branch had to be there to be analyzed, basically. Might also have standards. So is there any kind of a organizational standard that we have to code to? So these are all things to consider. And then on the right side, we have external requirements. So these are going to be things coming from the outside. So interoperability. Are we publishing an API for others to query? Are we reaching out to other people? Right? How are our systems going to mesh with other systems, internal and external? We could actually write requirements for that. We might have ethical requirements. So we spent a lot of time talking about ethics, right? Early on. I gave you my fire and brimstone speech, and then we looked at all those case studies. Are there any ethical components to what you're building? And this might not just be catastrophic. It might be something with your data management policies, right? What kind of deep dive into customer data will you be doing? These are things to consider, right? Then on the right side, we have legislative, so things from governing bodies coming in. Do we have privacy requirements, right? Are you dealing with GDPR from Europe, or are we going to be dealing with any kind of privacy concerns coming out of the current spotlight being shined on all of our social media giants? Do we have safety concerns? All right, are you building a safety critical system which is holding people's lives in your hand by strictly coding it? So we will have this to deal with as well. All of these things are technically non-functionals. So those are the different branches that we have. Now, when we start trying to elicit these requirements, meaning we're trying to get these requirements out of our customers and clients, you might go to a customer meeting. Let's say you're filling the analyst role, you're trying to get requirements for your project. And I should mention, you might not just be a developer, you might be an analyst, you might be a tester. There's a good chance you fulfill multiple roles in whatever company you end up with, or even startup or nonprofit, right? They're all going to have kind of a similar structure, I would imagine. But you go to talk to somebody, call them up on the phone, do a Zoom, whatever it's going to be, and then you ask them, well, what do you want your system to be like? Well, it should be user-friendly. Thank you, that was not helpful. What about failures? What kind of uptime are we expecting? Well, we wanted to respond quickly to failures. Okay. Do you want it to respond within 10 seconds? Can we take the night to go manually reboot your servers? Again, what I'm trying to kind of get to you is that requirements should be something you can test, something that you can validate later on or verify, right? So user-friendly tells me absolutely nothing. This year, a user-friendly website is responsive. 10 years ago, user-friendly was frame sets. Okay, so the point is to get as much detail as possible so you can write good requirements for your developers and for your team. So what does user-friendly mean? Does that mean we support 20 different screen resolutions? Does that mean it's accessible? Does that mean the buttons are big enough for, an elderly parent to be able to click? Right? What does user-friendly mean? So we have to try and nail these down. Same thing to some of these other ones. Recover from failure quickly. Respond to requests quickly. Quickly is not a great term. So if you end up with requirements like this, it's difficult to verify. That's why it's bolded and in red. They should be precise. We can test non-functional requirements. It is just difficult if they are vague, right? So if you're going to go through this process of creating requirements, of laying them down and defining them, they need to be specific. It's kind of the takeaway here. And that's why I said functionals tend to be a lot easier to test. Oh, why wouldn't you? Sorry, the sarcasm in me just wants to come bubbling out to that. Yes, be specific instead of using buzzwords. Absolutely. Avoid buzzwords at all costs, in real life and in your requirements definition. Absolutely. All right, so I just pulled up a random image off of Google Images for non-functional requirement examples. Because it turns out not a lot of companies want to part with their requirement specs. But here are some interesting ones. So this is basically for an IT type of environment. You can define requirements for IT jobs too. So employees shall be forced to change their password the next time they log in if they have not changed it within the length of time established as password? Mike Tyson now. Password expiration duration. So this is a good requirement in that it is flexible yet specific. So what this means, you go to a Windows machine, or I guess, any kind of machine, you can tie these all into your domain controllers or whatever you're using. I sit down and I go to log in. I get a pop-up. You have not changed your password in the last 120 days. Okay, this is a problem for IT people, right? So change your password. Okay, no problem. User experience, fine. Just go through and do that. But for testing this is something that we can actually test. It is vague, right? What the heck is the password expiration duration, you might ask? Well, this is a field in your domain controller, right? If you're using Windows, this is right in your domain controller. If you're in Linux, this would be in like your LDAP implementation, just to throw some acronyms at you, assuming you know what they are. Basically, your server management software, right? There is a field called password expiration duration, or close to that. There will be a field that has a value, right? We can test that value. Initial password may never be reused. Again, very, very testable. Related to privacy, so we can slot this into a non-functional. So kind of a good list to peruse at your leisure. So what we will do is actually end here, and I'm kind of curious, because I want to ask you guys something. So we've been talking about requirements, the artifact so far, right? Functional, non-functional, the different levels. These are all artifacts for your process. Requirements engineering is a whole field in and of itself, right? It is an engineering process, meaning that it's very rigorous and that we have very specific steps to follow to define requirements, to verify them, make sure that they are good for your team. So development, this is kind of what we've been talking about so far, and we'll even get into things like interviews and questionnaires and things of that nature to actually define requirements. Management's the other side of the thing, of the coin. And to give you the preview, management's where we basically have a management tool, kind of like configuration management from last time, where we actually have these requirements in there. They can be iterated upon, they can be refined, they can be linked to other things. So we're effectively managing our requirement spec. Why do we have to do both, is my question to you. So let's say I go through months of effort to define requirements. My team's happy, my manager's happy, everybody on the project's happy with the requirements. Have our 200-page software requirement spec. Why do I now have to go through a management procedure for them? Right, why do I have this extra overhead? Organizational purposes. Sure. That's definitely one reason why. We need to be able to organize our requirements according to our software engineering process. That's definitely one part, sure. Maybe what I'll do is I'll leave you with one keyword, and it's the same one from last time, consistency. Presentational, yeah, so we can organize them quite nicely as well, yeah. But we can be consistent with the tool, with the management process, right? We can consistently have a set of requirements which everybody's on board with. We might have revisions. If we have a tool, everybody can be on board with the newest edition or something of that nature. We have traceability between requirements to test cases to artifacts, all linked in here as well. So basically, there's a lot of things going on here. Requirements engineering can be a job in and of itself. So if this is something that tickles your fancy, I would definitely recommend it. It's a very, very important part of the software engineering process. My research area too. If anybody's wondering why I'm so excited about this, he said in a monotone voice. All right, so class is over and the weekend starts now. Does anybody have any questions on today or on the homework that's due Tuesday night or anything like that? What recommendation do you have for meeting minutes for this week? Just requirements, non-functional, and functional. So last week you had requirements for your homework. This week it's going to be whatever your team needs to talk about. So I don't have a specific content. So just follow the template that's in GitHub for you all. And there's not a Blackboard turn-in, so just either keep it until you're ready with your team repos or check it in if you've already forked the base repository. So what did you talk about this week? What has to be done next week? That kind of thing. Anytime. Alrighty. Other than that, have a wonderful weekend. I will see you all Monday, and we will continue on with requirements. Have a great weekend, everybody.
To be read. To draw a red line with green ink is, well, if it's not exactly impossible, it's pretty close to being impossible.
What does that even mean? Impossible.
I mean, it is possible there are some people, say, suffering from color blindness, for whom the color of the lines doesn't really make a difference. And what exactly did you mean when you talked about the transparent ink?
How to better explain? I'm sure you know what transparent means.
Yes, I do.
And what a red line means. I hope I don't need to explain to you.
Of course not.
Well, you need to draw a red line with transparent ink.
Could you describe what you imagine the end result would look like?
Come on, Anderson, what have we got here? Kindergarten?
No, I'm just trying to get a...
Let's not waste our time with these unproductive quarrels. The task has been set, the task is plain and clear. Now, if you have any specific questions, then go ahead.
You're the expert here.
All right, let's leave aside the color for the moment. You had something there also relating to perpendicularity.
7 lines, all strictly perpendicular.
To what?
To everything amongst themselves. I assumed you know what perpendicular lines are like.
Of course he does. He's an expert.
2 lines can be perpendicular. All 7 can't be simultaneously perpendicular to each other. I'll show you. This is a line, right?
Yes.
And another, is it perpendicular to the first line?
Well,
Yes, it is perpendicular.
exactly.
Wait, I'm not done. And a third one, is it perpendicular to the first line? Yes, it is. But it doesn't cross the second line. They're both parallel, not perpendicular.
Suppose so.
There it is. 2 lines can be perpendicular.
Can I
but
have the
isn't it?
pen? How about this?
This is a triangle. It's definitely not perpendicular lines. And there are 3, not 7.
Why are they blue?
Indeed, I wanted to ask that myself.
I have a blue pen with me. This was just a demonstration.
That's the problem.
And that's
Your
all I can
lines are
take.
blue. Draw them with red ink.
It won't solve the
Bye,
problem.
everybody.
Well, how do you know?